Good morning, class. Let us have some doubts from assignment 3. And the first one is, if n is an odd integer, then n square minus 1 is divisible by 8. So, when it comes on the odd integers are of the type, when we are saying odd numbers, so odd numbers can be of the type 2q plus 1. This is always representing an odd number, and it could be of the type 4q plus 1 and 4q plus 3. This will also represent always the odd numbers, and also you can say it is 6q plus 1, 6q plus 3, and 6q plus 5. This is also representing an odd number, and 8q plus 1, 8q plus 3, 8q plus 5, and 8q plus 7. This is also representing an odd number. So when it is come on discussing about the odd numbers, you have to prove that when n is your odd, then n square minus 1 is divisible by 8. So if we do the square of this n, then we won't have 8 in that one, so we'll ignore this one. And when we do the square of this one, we can get 8 there, because 4 square is 16, and it is 16 is in the table of 8. So we'll take this one to avoid the long process. We can take this one and this one also, but this is very long process to solve this question. So we are taking the odd numbers in the form of 4q plus 1 and 4q plus 3. Let odd numbers are, this is not the part of question, you can do this one in rough part. Numbers are 4q plus 1 and 4q plus 3. So if we need to prove that n square minus 1 is divisible by 8, our number is we have n square minus 1. Let n is now your 4q plus 1. First of all, when you take n as 4q plus 1, then you will put n as 4q plus 1 here. So your number, this relation, you can write this as r equal to n square minus 1. Then r is your 4q plus 1 whole square minus 1. So if you do the square of this one, then you will have 16q square plus 1 and plus 8q minus 1. So this will be cancelled out, then you will have 16q square plus 8q. You can take 8 common from here, and this is 2q square plus q. Since it is multiple of 8, you can write this some another value, let lambda is this one. So you can say that which is divisible by 8. So first of all, you get the first number 4q plus 1, and you prove that this one is multiple of 8 here. Now you will take this odd number here, this one is also odd, this is 4q plus 3. Let n is now your 4q plus 3, and your relation will become r is your 4q plus 3 whole square minus 1. So opening this square, you will have 16q square plus 9 plus 24q minus 1. So 9 minus 1, you will have 8 here. It is 16q square plus 8 plus 24q. You can take 8 common from all. This is 2q square then plus 1 plus 3q. So you can also see here that it is multiple of 8. Therefore you can also write r is divisible by 8. So you can say that every positive odd integer is divisible. Then for n is every positive odd integer, n square minus 1 is divisible by 8 always. So hence you can say that n square minus 1 for n is odd is divisible by 8 always. So that is the proof of the first doubt, and let us discuss the second one now.